All right, so if you're building anything on AWS, you're going to hit this fork in the road, and it's a big one. How do you manage all your traffic? And look, this isn't just about, keeping the lights on. It's about picking the right tool for the job. So today, we are going to break down AWS load balancing and make that choice super, super clear for you.
So picture this. It's the moment you've been dreaming of, right? Your app just went viral, users are flocking to it, and then, bam, everything just grinds to a halt. Your servers are totally overwhelmed, and your big moment of triumph suddenly turns into this frantic firefight. Yeah, it's what they call a good problem to have, but trust me, it's still a very, very real problem. So what's happening behind the scenes? Well, it's actually pretty simple. A single server, I don't care how powerful it is, has a breaking point. And when all those requests flood in at once, performance just nosedives until the server pretty much just gives up. And this is the exact moment our hero of the day steps onto the scene, the load balancer.
And in the AWS universe, that hero is called Elastic Load Balancing, or ELB for short. You can think of it as this one single, super reliable front door for all your traffic. But it does way more than just distribute requests. It's constantly checking on the health of your servers, making sure to send traffic only to the ones that are healthy. And the Elastic part, it scales up and down automatically as your traffic comes and goes.
Okay, the easiest way to wrap your head around this is to think of it like a really smart traffic cop standing at a super busy intersection. Instead of just letting all the cars get jammed up on one street, this cop is intelligently directing them down multiple open roads. The result? A nice, smooth, even flow for absolutely everyone.
So how does this traffic cop actually, direct the flow? Well, it's not just one thing. It's actually a system with three key parts all working together in perfect sync. Let's take a look under the hood at the anatomy of this whole traffic manager.
It's basically a super clean three-step flow. First, you've got the listeners. Think of these as the ears of the operation. They're just listening for connection requests on specific ports, like port 80 for web traffic. Okay, so once a request comes in, the load balancer itself, which is the brain of the whole thing, kicks in. It looks at the request and uses a set of rules to decide where it should go. And then finally, it sends that request off to a healthy server inside what's called a target group. It's that simple, and it's what makes sure no single server gets swamped.
Okay, but here's the thing. That brain we just talked about, it's not a one-size-fits-all deal. AWS has a few different types of load balancers, but honestly, your most critical choice is almost always going to come down to two absolute powerhouses, the application load balancer and the network load balancer.
Let's bring back our traffic cop analogy for this, because it's perfect. The application load balancer, think of that one as the intelligent inspector. This cop doesn't just glance at the car. They look inside to see what it's carrying, where it's specifically trying to go. Now, the network load balancer, that's the ultra-fast operator. This cop couldn't care less what's inside the car. They just read the destination address and get it there as fast as humanly possible.
So, let's see how that analogy plays out in the real technical world. The application load balancer, or ALB, operates at what's called Layer 7, the application layer. That means it actually understands protocols like HTTP and HTTPS. It can look at the content of a request, the URL path, the headers, all that good stuff, and make really smart routing decisions. The network load balancer, or NLB, works way down at Layer 4, the transport layer. All it sees are IP addresses and ports. By totally ignoring the application content, it can move packets at just blistering speeds. It's way, way faster, but it's also a lot less aware of what it's actually handling.
Okay, let's really zoom in on the ALB's superpower, which is that flexible, content-based routing. This is truly where our intelligent inspector shines, and honestly, it's what makes it an absolute game changer for modern stuff like microservices.
This flexibility is just incredibly powerful. It means you can say, hey, any requests for /images, send them to this group of servers. Any requests for /API, they go over here. You can even have one single load balancer handling multiple websites, like news.example.com and store.example.com, just by looking at the hostname. It's this kind of fine-grained control that makes complex things like microservices actually work in the real world.
All right, so if the ALB is the smart one, the NLB is just the raw, high-performance beast to the operation. Its entire design is laser-focused on just two things: pure, unadulterated speed and massive, massive scale.
And look, when I say scale, I really mean it. We're talking millions. A network load balancer is built from the ground up to handle millions of requests every single second, with latency so low it's measured in microseconds. This is the kind of raw horsepower you absolutely need for things like high-frequency trading or massive online games, where every single millisecond counts.
Okay, so you've got the intelligent inspector and the ultra-fast operator, the brains and the brawn. So, how in the world do you decide which one to use? Let's break it down into a really simple cheat sheet. This will help you make the right call every single time.
You're going to reach for an application load balancer, the ALB, when a few things are true. First, if you're building a web app or an API that uses HTTP or HTTPS. Second, if you need to route traffic to different microservices based on things like the URL. And third, if you want some of those fancier features like user authentication right at the load balancer, or if you're routing to Lambda functions. Basically, if you need that flexible, content-aware routing, ALB is your answer.
Now, you're going to pick a network load balancer or an NLB when your priorities are totally different. If you need the absolute highest performance and the lowest possible latency, NLB is the winner, hands down. If you're handling anything that's not web traffic, think gaming, IoT, that kind of stuff, NLB is your tool. And here's a really critical one. If you need a static IP address for your service that never, ever changes, the NLB is your only option. That's a huge deal for a lot of systems.
So while the choice seems pretty clear-cut right now, ALB for smarts, NLB for speed, modern apps are starting to blur those lines. You got new protocols like gRPC and WebSockets that kind of need a bit of both. They need some application awareness, but also that network-level performance. And it really forces us to ask a bigger question as we design new systems. Where does the network part of our stack actually end, and where does the application truly begin? It's something to chew on for your next big project.